identify the objective of the problem and represent it with Z. That is, either it is maximize or minimize. The maximum time available for cutter is 104 hours and for finisher 76 hours are available. What is the cost given? Since cost is 70 for X and 30 for Y, therefore the objective function is to maximize. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important and the easiest chapter, that is linear programming problem, LPP, linear programming problem. Now before going to exact chapter, now the weightage for this chapter is just a 5 marks question you will get from this. So one question, so that is for 5 marks. 5 marks from this chapter, one full question. Now here in this session I am going to discuss regarding the linear programming problems, that is the formation of linear programming problems and what are the terms involved in formation of a linear programming problem. Now before going to the formation, let us discuss some terms. What is a linear programming problem? What is an objective function? And how to formulate a LPP model. Now definition, what is a linear programming problem? Means linear programming deals with optimization of a linear function of variables subjected to a set of linear constraints. So that means a linear programming problem is the optimization of a linear function. Here the optimization is nothing but maximization or a minimization. So the function, that is maximization or minimization of a linear function of variable subject to a set of linear constraints. So a linear programming deals with the optimization, that is maximizing or minimizing a linear function of variables subjected to a set of linear constraints. Let us know how to form a linear programming problem. So formation of a linear programming problem, then formation of a linear programming and finding the solution, and finding the solution of a linear programming problem using graphical method. These are the concepts which we are going to study in this chapter. Now let us discuss in detail regarding the formation of a linear programming problem. So how to form a linear programming problem, LPP. Consider the following steps for the construction of a linear programming problem. So for the construction of the model of LPP, these are the steps involved. What are the steps? Step number 1, identify the unknown variables. Just identify the unknown variables, also known as the decision variables, and denote them in terms of algebraic symbols, right? So first identify the unknown variables and they are also known as the decision variables. So just identify the decision variables and denote them in terms of the algebraic symbols. Second step, identify the objective of the problem and represent it with the Z. So just identify the objective of the problem and represent it with Z. That is, either it is maximize or a minimize. So the objective function may be maximum Z or a minimum Z. Next, third one, identify all the restrictions. All the restrictions, also known as the constraints, represent them as the equations or inequalities in terms of the symbols. So represent them in terms of an inequalities, less than or equal to, greater than or equal to, or in terms of the symbols. Now next, these are the few steps which we are followed to form a linear programming problem model. Now based on this, let us take one small example how to form a linear programming form. So formation of LPP, linear programming problem. Now the first problem, what is the first problem? Just go through the problem. What is the problem? This is a statement problem. A resourceful home decorator. So home decorator Anantu manufactures two types of lamps, lamp A and lamp B. So the home decorator, Mr. Anantu, will manufacture how many types? 2 types of lamps, say lamp A and lamp B. Both lamps go through 2 technicians. So both the lamp A and B go through 2 technicians. First one is the cutter and the second one is the finisher. There are 2 technicians. One is the cutter, another one is the finisher. Lamp A requires 2 hours of cutters. So lamp A requires 2 hours of cutting process and 1 hour of finishing time. So lamp A requires 2 hours for cutting and 1 hour for finishing. Similarly, the lamp B requires 1 hour for cutter's time and 2 hours of finisher's time. Right. So for A and B, the time for cutting and finishing is given. Then the cutter has certain condition is given. What is the condition? The cutter has 104 hours and the finisher has 76 hours. So the maximum time available for cutter is 104 hours and for finisher 76 hours are available. Find, that is, profit. Profit of a lamp A is rupees 6 and profit of a lamp B is rupees 11. Assuming that she can sell all that she produces, formulate the LPP. Right. So assuming that she can sell all the products produced and form an linear programming problem for this model. Now here the very important concept is profit. Profit on lamp A and profit on lamp B is given. Assume that she can sell all that she produces the products, formulate an LPP. That means here, so the objective function is the profit. That means the objective function is to get the maximum amount. The objective function is max Z. Now let us formulate how to formulate this, right? So this is the given problem. So now, so here what is given? The manufacturer makes X and Y lamps of type A and B. So the manufacturer will make X and Y lamps of type A and type B, right? So the total profit, which is the objective function, the total profit is the objective function. What is the total profit? So for lamp A 6 rupees, for lamp B it is 11 rupees. So total profit is 6x plus 11y. Right, this is the total profit. Okay. So let us represent this as Z. Therefore, the objective function is Z is equal to 6x plus 11y. Now, just the total time used by the cutter. So the total time taken by the cutter to manufacture X type of lamp A and Y type of lamp B is, just go to the problem again. So what is the time taken? A requires 2 hours cutting time and lamp B requires 1 hour cutting time. So therefore this can be written as 2x plus y. 2x plus y. So the cutting time for X type of lamp A and Y type of lamp B is 2x plus y. And what is the maximum time given here? So the cutter has 104 hours. Maximum is 1 hour, 104 hours means, therefore this can be written as 2x plus y is less than or equal to 104. This is the first constraint, right? Similarly, the finisher. So the total time taken by the finisher of X type of A lamp and Y type of lamp B, what is the time we have? So cutter will require 1 hour to finish A and 2 hours to finish B. So that is, we have X plus 2Y, and what is the maximum time available is 76 hours. So which is less than or equal to 76. That's it. Okay. Hence the required LPP. Therefore the required LPP is maximum Z is equal to, this is the objective function, that is 6x plus 11y subjected to the constraints. Subjected to the constraints. What are the constraints? These are the two constraints, that is 2x plus y is less than or equal to 104. So x plus 2y is less than or equal to 76, and the non-negative restrictions are x is greater than or equal to 0 and y is greater than or equal to 0. So this is the required LPP model, right? Now hope you followed. Move on to the similar type problem. Pratik wants to decide the constituents of diets which will fulfill his daily requirements of proteins, fats and carbohydrates at minimum cost. The combination is made among two foods, that is product A and product B, whose contents are indicated in this chart, right? So Pratik wants to decide the constituents of diet which will fulfill his daily requirements of proteins and fats, carbohydrates at minimum cost. The combination is made among two products, that is A and B, whose contents are given. So we have to formulate the LPP for this. Already they have given. So the food are nothing but, what are the food? Proteins in milligrams, fats in milligrams, carbohydrates in milligram, and the cost per unit is also given. So type A and type B. In type A, so 5 milligrams of proteins and 2 milligrams of proteins in type B. Similarly, fat in A is 6 and in B it is 5. Carbohydrates in A it is 4 milligrams, in B it is 3 milligrams. And the cost of this A is 70 and B is equal to 30. So minimum requirements are 800, proteins 800, fats 200 and carbohydrate 700. So this is given. So from this easily you can formulate an LPP. Now let us represent the number of unit of food of type A as X and the number of units of food of type B as Y. So let us represent the number of units of food A as X and B as Y. Now, so what is the cost given? Since cost is 70 for X and 30 for Y, therefore the objective function is to maximize. So therefore Z is equal to, write down the objective function. Now Z is equal to 70x plus 30y. So since it is the profit, therefore the objective function is max Z. Maximum of Z is equal to 70x plus 30y. This is an objective function. Now subjected to constraints. What are the constraints here? Now, so therefore we can formulate, since proteins, for proteins this is 5x plus 2y, and what is the minimum requirement is 800, means minimum is 800 means greater than or equal to 800 and more than that. Next, second type. So for fats, 6x plus 5y, 6x plus 5y is greater than or equal to 200. And the third one is carbohydrate, 4x plus 3y, 4x plus 3y is greater than or equal to 700. Okay, so hence the required LPP problem is, therefore the required LPP model is, the objective function is maximum Z is equal to 70x plus 30y subjected to constraints, STC subjected to constraints. What are the constraints? 5x plus 2y is greater than or equal to 800. Then 6x plus 5y is greater than or equal to 200. Then 4x plus 3y is greater than or equal to 700. And the non-negative restrictions are x is greater than or equal to 0 and y is greater than or equal to 0. This is the required LPP. Hope you followed. Okay. Now move on to the next problem, third type. So third one, Arvind, a chemist, provides his customers at the least cost the minimum daily requirements of two vitamins A and B, two vitamins A and B by using a mixture of two products M and N. The amount of each vitamin in 1 gram of each product, the cost per gram of each product, and the minimum of daily requirements are given here. So, Arvind, a chemist, provides his customer at the least cost the minimum daily requirement of two vitamins A and B. Right. So, you will provide two vitamins A and B by using a mixture of two products. So, the two products are M and N are the two products. The amount of each vitamin in 1 gram of each product, the cost per gram of each product, and the minimum daily requirement are all given here. So, what is the given table? The product, what are the two types of product? Product M and N. So, vitamin A and vitamin B. So, for M, the vitamin A is 6 and vitamin B is 2. Minimum requirement of each vitamin is 12 and the cost per gram of each product is 20. And similarly, for the type N, the vitamin A is 2, vitamin B is 2 and the minimum requirement of each vitamin is 8 and the cost per gram of each product is rupees. So, we have to formulate the linear programming problem. Very simple problem, right? Now, let us represent the amount of product M as X, the amount of product M as X and the amount of product N as Y, right? The amount of product M as X and the amount of product N as Y. So, using this, let us represent M as X and N as Y using this. Now, just by looking through the table, we can say what is the objective function? The objective function is cost, means again it is the maximization. So, maximum of 20x plus 16y, 20x plus 16y. So, let us represent the objective function as z is equal to 20x plus 16y. Now, the constraints, what are the constraints? Subjected to constraints. Here, the cost per gram of each product is given. This is given, right? And the minimum requirement of the each vitamin is 12 and 8. That is also given. Now, therefore, since the objective function is z is equal to 20x plus 16y, so subjected to the constraints, therefore, the objective function is maximum z is equal to 20x plus 16y subjected to the constraints. What are the constraints here? So, 6x plus 2y subjected to the constraint 6x plus 2y, 6x plus 2y, minimum requirement is 12. So, greater than or equal to 12 and the second equation is 2x plus 2y, 2x plus 2y is greater than or equal to 8. And the non-negative restrictions are x is greater than or equal to 0 and y is greater than or equal to 0. This is the required linear programming problem. So, hence max z is equal to 20x plus 16y subjected to the constraints 6x plus 2y greater than or equal to 12, 2x plus 2y greater than or equal to 8 and x is greater than or equal to 0, y is greater than or equal to 0. That's it. Okay, very simple method. Now, let us move on to the next problem. A company owned by Swati can produce two types of high quality shoes. So, a company owned by Swati produces two types of high quality shoes. Each shoe of first kind requires thrice as much as the time as the second. So, each shoe of first kind requires thrice as much as time as the second kind. If all the shoes are of second kind only, the company can produce a total of 600 pairs a day. Only a maximum of 150 pairs of the first kind and 400 of second kind can be sold a day. If the profit per pair of the first kind is rupees 400 and similarly the profit per pair of the second kind is rupees 150, then formulate the linear programming problem. Same as that of the previous problem. Now, let us represent the shoes produced by the company as X and Y of first kind and second kind. So, then what is the given condition here? Two types of high quality. Each shoe of the first kind requires thrice as much each kind. So, what is given? First type will require x plus 3y. X plus 3y. So what is the given condition? Each shoe of first kind. Each shoe of first kind requires thrice as much as the time as the second kind. So what is given? That is 3x plus y. Right. So which is less than or equal to, what is the time here? We have 600. That is, the given condition is 3x plus y is less than or equal to 600. That means it can produce 600 pairs. So what is the given condition? So the company only a maximum of 150 pairs of first kind and 400 kinds of second. So first kind is 150 and second kind is equal to 400 can be produced here. So therefore what is given condition? So therefore x is less than or equal to 150 and y is less than or equal to 400. X is less than or equal to 150 and y is less than or equal to 400. Since the production is neither negative, so therefore we can take x is greater than or equal to 0 and y is greater than, that is non-negative restrictions. Since it is the profit, so therefore the objective function is the maximization. So max z is equal to, what is the cost? So here the maximum, if the profit of the first kind is 400 and the second kind is 150. So therefore, so 400x plus 150y is the objective function. So maximum z is equal to 400x plus 150y. Right. So hence the required LPP, therefore the required LPP is, what is the objective function? Maximum of z is equal to 400x plus 150y subjected to the constraints. What are the constraints? 3x plus y is less than or equal to 600, x is less than or equal to 150, y is less than or equal to 400, and the non-negative restrictions x comma y is greater than or equal to 0. This is the required LPP. Hope you followed. Okay. This is how we are going to formulate the given problem as an LPP model. This is how the formation of a LPP problem can be done. Hope you followed. That's all regarding today's session. I hope you got an idea how to form an LPP. So that's all regarding today's session. Let us meet with a different type of problems in the next session. Thank you. Thank you very much.